Using cheap electrical tape for electrical repairs is a dangerous false economy. Low-quality tape doesn't last and is more likely to fail. This can lead to fires or other dangerous situations. It's always best to use high-quality tape specifically designed for electrical work to ensure safe and reliable repairs. Consider cases where cheap tape led to disastrous outcomes. A customer once used low-quality tape to fix a loose wire. The tape failed, causing a house fire that destroyed their home. Another time, cheap tape was used to repair a car wire, leading to the car stalling in the middle of the road and narrowly avoiding an accident. Choosing high-quality tape for electrical work is worth the extra cost because it ensures safe and reliable repairs and avoids potential hazards. Electrical tape is designed to insulate electrical wires and connections, preventing short circuits and electrical shocks. High-quality electrical tape is made from materials that are resistant to heat, moisture, and chemicals, ensuring that it will not degrade over time. It also has a strong adhesive that will keep it securely in place, even in harsh conditions. Conversely, low-quality electrical tape is often made from cheap materials that are not resistant to heat, moisture, or chemicals. The adhesive on low-quality tape may also be weak, causing it to peel or fall off over time. When electrical tape fails, it can expose bare wires, which can create a fire hazard or cause an electrical shock. A short circuit can occur when a bare wire comes into contact with another wire or a grounded metal object. This can cause a surge of electricity that can overheat the wires and start a fire. An electrical shock can occur when a person comes into contact with a bare wire. This can cause serious injury or even death. Using high-quality electrical tape is an important way to prevent electrical fires and shocks. When selecting electrical tape, look for tape that is specifically designed for electrical repairs. This type of tape will be labeled as electrical tape or insulating tape. Make sure that the tape is rated for the voltage of the wires that you are repairing. The voltage rating will be printed on the tape. Choose tape that is resistant to heat, moisture, and chemicals. This type of tape will last longer and provide better protection against electrical hazards. Follow the manufacturer's instructions when applying electrical tape. Make sure that the wires are clean and dry before applying the tape. Overlap the tape by at least 1/2 inch to ensure a good seal. Do not stretch the tape too tightly, as this can cause it to lose its adhesive properties. If you are not comfortable working with electricity, hire a qualified electrician to make the repairs. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical hazards. In addition to using high-quality electrical tape, there are other steps that you can take to prevent electrical fires and shocks. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Use the correct size circuit breaker for each circuit. A circuit breaker that is too large will not protect the circuit from overloading. Inspect electrical cords and plugs regularly. Replace any cords or plugs that are damaged. Keep electrical appliances away from water. Water can conduct electricity, which can cause an electrical shock. Install ground fault circuit interrupters, or GFCIs, in the areas where water is present, such as bathrooms and kitchens. GFCIs can detect electrical leaks and shut off the power to prevent electrical shocks. Have your home's electrical system inspected by a qualified electrician every few years. An electrician can identify potential electrical hazards and make repairs before they cause a problem. By taking these precautions, you can help to prevent electrical fires and shocks and keep your home safe. Always remember to turn off the power at the circuit breaker before working on any electrical wiring. This will prevent you from getting an electrical shock. Use a voltage tester to make sure that the power is off before you start working. Wear rubber gloves and shoes when working with electricity. Rubber is a good insulator and will help to protect you from electrical shock. Work in a well-lit area. This will help you to see what you are doing and avoid making mistakes. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical hazards. Also, remember that different types of electrical tape exist for various applications. Firstly, general-purpose vinyl electrical tape is suitable for most household electrical repairs. Secondly, high-temperature electrical tape is designed for use in high-heat environments, such as near motors or appliances. Thirdly, rubber splicing tape is used to create a waterproof seal around electrical connections. And fourthly, self-fusing silicone tape is ideal for insulating and protecting wires and connections in extreme temperatures and harsh environments. Always choose the right type of tape for the job to ensure a safe and reliable repair. Furthermore, it is important to properly prepare the wires before applying electrical tape. Firstly, ensure that the power is turned off to the circuit you are working on. Secondly, clean the wires to remove any dirt, grease, or corrosion. Thirdly, if the wires are damaged, repair them before applying tape. Fourthly, when wrapping the tape, start by overlapping the tape onto the wire insulation. Fifthly, stretch the tape slightly as you wrap it around the wire, ensuring a tight seal. Sixthly, continue wrapping the tape until the entire connection is covered, overlapping each layer. Seventhly, for added protection, apply a second layer of tape. And eighthly, press the tape firmly to ensure it adheres properly. In addition to electrical tape, other materials can be used for electrical insulation. Wire connectors, also known as wire nuts, are used to connect two or more wires together. They provide a secure and insulated connection. Heat shrink tubing is a plastic tube that shrinks when heated, providing insulation and protection for wires and connections. Electrical potting compound is a resin used to encapsulate and protect electrical components from moisture, vibration, and chemicals. Always choose the appropriate insulation material for the specific application and follow the manufacturer's instructions. When working with aluminum wiring, it is crucial to use connectors and tape specifically designed for aluminum. Aluminum wiring expands and contracts more than copper wiring, which can loosen connections over time. Using the wrong type of connector or tape can lead to overheating and fire hazards. Look for connectors and tape that are labeled as Al/Cu or aluminum compatible. These materials are designed to accommodate the expansion and contraction of aluminum wiring and provide a secure and reliable connection. Also consider the environment where the electrical work is being done. If the area is damp or wet, use waterproof connectors and tape. If the area is exposed to chemicals, use chemical-resistant materials. If the area is subject to high temperatures, use high-temperature rated materials. Choosing the right materials for the environment will ensure that the electrical connections are properly insulated and protected. Regular inspection of electrical wiring and connections is important for maintaining electrical safety. Look for signs of damage, such as cracked or frayed insulation, loose connections, or corrosion. If you find any damage, repair it immediately. It is also important to have your home's electrical system inspected by a qualified electrician every few years. An electrician can identify potential electrical hazards and make repairs before they cause a problem. Electrical safety is everyone's responsibility. By following these tips, you can help to prevent electrical fires and shocks and keep your home and family safe. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work. Working with electricity can be dangerous, and it is important to take precautions to protect yourself and others. Knowing the color codes of electrical wires is also essential for safe electrical work. In North America, the standard color codes are as follows. Firstly, black wires are typically used for hot wires, which carry electrical current from a power source to the outlet or device. Secondly, white wires are typically used for neutral wires, which carry electrical current back to the power source. Thirdly, green or bare copper wires are used for ground wires, which provide a path for electrical current to flow safely to the ground in the event of a fault. Fourthly, red wires can be used as hot wires in some cases, such as for switch legs or three-way switches. And fifthly, blue and yellow wires are sometimes used as hot wires in commercial or industrial applications. It is important to note that these color codes may vary in some countries or regions. Always check the local electrical codes and regulations before working on any electrical wiring. When working with electrical wiring, It is also important to understand the different types of wire gauges. Wire gauge refers to the thickness of the wire, which determines how much electrical current it can safely carry. The smaller the gauge number, the thicker the wire and the more current it can carry. For example, 12-gauge wire is thicker than 14-gauge wire and can carry more current. The appropriate wire gauge for a particular application depends on the amount of current that the circuit will be carrying. The National Electrical Code, or NEC, provides guidelines for selecting the correct wire gauge for different circuits. For example, the NEC typically requires 14-gauge wire for 15-amp circuits and 12-gauge wire for 20-amp circuits. Using the wrong wire gauge can be dangerous and can lead to overheating, fire, or electrical shock. Always consult the NEC or a qualified electrician to determine the appropriate wire gauge for your specific application. In addition to wire gauge, it is also important to consider the type of wire insulation. Wire insulation is the non-conductive material that surrounds the wire and protects it from damage and electrical shock. There are many different types of wire insulation available, each with its own specific properties and applications. Some common types of wire insulation include firstly, thermoplastic high heat resistant nylon coated, or THHN, which is a common type of insulation used for general purpose wiring. Secondly, thermoplastic heat and water resistant, or THW, which is similar to THHN but is also water resistant. Thirdly, cross-linked polyethylene, or XLP, which is a high-temperature insulation that is often used in industrial applications. And fourthly, mineral insulated, or MI, which is a type of insulation that is used in extreme environments such as high-temperature or corrosive environments. The type of wire insulation that you choose will depend on the specific application and the environmental conditions. Always consult the NEC or a qualified electrician to determine the appropriate type of wire insulation for your specific needs. When making electrical connections, it is important to use the correct type of connector. There are many different types of connectors available, each designed for a specific purpose. Some common types of connectors include firstly, wire connectors, which are also known as wire nuts, are used to connect two or more wires together. Secondly, solderless connectors, which are also known as crimp connectors, are used to connect wires without soldering. Thirdly, terminal blocks, which are used to connect multiple wires together in a neat and organized manner. Fourthly, twist-on-wire connectors, which are a type of connector that is twisted onto the wires to make a connection. And fifthly, push-on-wire connectors, which are a type of connector that allows you to simply push the wires into the connector to make a connection. The type of connector that you choose will depend on the specific application and the type of wires that you are connecting. Always follow the manufacturer's instructions when using electrical connectors. When working with electrical wiring, it is also important to be aware of the potential hazards. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Some common electrical hazards include firstly, electrical shock, which can occur when you come into contact with a live wire. Secondly, electrical burns, which can occur when you are exposed to high voltage electricity. Thirdly, electrical fires, which can occur when electrical wiring overheats or shorts out. Fourthly, arc flash, which is a sudden release of electrical energy that can cause serious burns and injuries. And fifthly, electrocution, which is death caused by electrical shock. To protect yourself from electrical hazards, always follow these safety precautions. Firstly, always turn off the power at the circuit breaker before working on any electrical wiring. Secondly, use a voltage tester to make sure that the power is off before you start working. Thirdly, wear rubber gloves and shoes when working with electricity. Fourthly, work in a well-lit area. Fifthly, never work with electricity when you are wet or standing in water. Sixthly, never overload electrical circuits. Seventhly, inspect electrical cords and plugs regularly for damage. Eighthly, replace any damaged electrical cords or plugs. Ninthly, keep electrical appliances away from water. And tenthly, install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms and kitchens. By following these safety precautions, you can help to prevent electrical accidents and injuries. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work.